And what I'm going to be talking about today is Sea-Air, a platform that we've developed as a high throughput, cost-effective, and portable air quality sensor. But to start off this presentation, my PI, Idogen, and the main project lead, Chris, will be talking about it.
The title of our project is Sea-Air. It aims to see through air, so that through computational imaging and sensing techniques, you can understand the number of particles, the types of particles in air that we're breathing in.
The particles are different bioaerosols like fungi, bacteria, and all these are integrated in such a compact flow.
And at the same time, it's very cost effective. As a result, you can actually deploy this in different parts of the building, at airports, at metro stations, as part of traffic lights. India, China, and Pakistan together are losing 2 million lives every year related to air quality. So this is only getting worse, and we need better technologies that is going to empower us to understand the air quality patterns as a function of space and time. And with that data, help change our own behavior as well as institutional and government policies that are going to help us mitigate air pollution on the side of things.
Thank you to the vote. Thanks to the vote from the American Foundation for putting together that video. So what I'm going to talk about is going to go a little bit more in depth, and hopefully, a lot of this stuff will be a little bit more interesting than just a brief overview there. So as Idogen mentioned, air quality is a huge life-threatening problem. If it doesn't kill you in some areas, it can cause lifelong respiratory problems. And as he mentioned, air pollution accounts for over 2 million deaths in China, India, and Pakistan alone. Best example in the recent years has been the images coming out of China. For example, this building in Beijing during a bad air quality day. And these are the types of things that we're really trying to understand and trying to figure out where they're coming from and how they're affecting the people around them. In 2014, in the Los Angeles area, the USC actually did this interesting study where previously, well, everyone knows that air quality around airports is very bad. But they did a study where they actually put a portable air quality sensor on a car and they drove around the east area from LAX, which is our international airport over there. And they saw that they had up to 4 times the micropollutants in the air compared to the baseline, up to 20 miles eastward. And this is because in Los Angeles we have these very nice constant winds that are pushing all this air pollution to the east side. And so these things we didn't know about, and we wouldn't know about unless we deploy something that's capable of measuring these air pollutants. Another thing, which is a problem that you might have in your own homes, are bioaerosols such as mold, pollen, which can grow inside your bathtubs in high humidity conditions. A lot of people, many fungal species especially, can cause allergic respiratory diseases, especially asthma. And so what you want to do is you also, in one of these air quality platforms, you also want to be able to quantify the types of mold, pollen, viruses, bacteria that you're starting to see in these, or that you know are growing inside these rooms. And this is actually a big thing that a lot of cities put a lot of time and effort into quantifying. So what we built, or based off of our last 10 years of research, is a computational microscope. This is the platform that Chris previously held in his hands. So you kind of see it's kind of something you can put in your hand and carry around with you. And the goal is that with this microscope, it'll pull in air, grab some air, it'll send those images that it's capturing to a remote server to process that data, and then it gets you the results back to your smartphone, to your laptop within half a minute or so. So I'll go briefly into the details of this. What we have is we have an air pump that's pulling air from the local air quality into the system, where an impactor-based system is collecting those particles onto a sticky substrate. And we're using lens-free microscopy to capture images of the holograms of these particles. And these holograms are then sent to a remote server for processing, computational processing, to return a microscope equivalent image to process, to do cell counting, object counting, and other types of measurement and analysis to get you the final results. And the current method, the current prototype we developed has a web interface that you can see here. where samples will be sent to the server and you get the GPS location from the device or the smartphone that you're using to send the images. We can analyze those to create particle density histograms, as you can see in the lower left. This is also a mobile applicable platform, so this is a screenshot from an iPhone device where you're seeing the same type of interface. If you scroll up a little bit more, you'll be able to select the samples and be able to see what the air quality is like in different parts of from your measurement. So we've deployed this initially as a wearable as well as a bikeable platform. So on the image on the left, Chris is wearing our platform as part of the backpack system. There's a button that they press on the left shoulder, and after they press it, the air is pulled in, the images are taken, it's sent to a server, and then the processed and sent back to the phone or web platform. In the future, we're also planning to integrate these with, for example, drones. And so this is, as I mentioned, can be very easily used for basically creating a network of air measurement tools. And so we're thinking of static nodes as well as dynamic nodes, those on cars as well as those on traffic lights and so on and so forth. And this whole system in the end, ideally, would be able to do a giant ground air coordinated effort for doing adaptive sampling of air quality. And these images would all be sent either, for example, through your Wi-Fi connection, through cellular data, to servers, which would then be processed. You could get those either as pollution reports online or as mission updates specifically to your smartphones, for example. And using this, we hope that we would be able to make a big impact on the world today. So these are just some brief highlights, but we're hoping that this would become a citizen-level deployable network, cost-effective, portable, easy to use, where we would be able to inform local communities to be able to make use of this platform in their local air quality to make effective changes, and also reserve things that we haven't seen before, such as the previous study that I mentioned with the Los Angeles LAX air quality from due to planes. And so we're looking for better management of these issues, and this could also be potentially used for defense and security technologies. So I'll have questions later, but also this afternoon at 5 o'clock I'll be putting on a demo of some of our lab technologies. Unfortunately, I do not have the Sierra platform with me, but I'll be showing some other technologies we've made. I'd like to thank all our funding sources as well. And thank you.
Thank you very much, all of you. This is extremely interesting, and I'd like to ask everyone to give me one last round of applause to all these winners for the fun. So we're at the point where we can ask these brilliant people for some questions. Let's see if I can get to the next Q&A slide. So if there's any questions out there, if you could run the microphone or somebody can help out with them. So there's a question over here. So just line them up and I'll point you out. I have a few questions of my own, so go ahead, sir.
No, I had a question, but how small can this get?
How small can you get?
The air sniffer, the air quality. Yes.
So it might be a good idea if you identify yourself.
I'm Doug Starfield. I'm a renewable energy systems engineer, but I have been interested in air quality because of the climate change issue, and I wanted to know also if they could sniff CO2 and give us the parts per million of that, so that citizens could presumably have a network of these, and they can walk around a city and have live streaming values of air quality.
Definitely. Is it you? Is it turned on? Hello? Oh, I think it worked now.
Yeah, it was.
Okay. I'll pass this on. Okay, sorry about the technical difficulties, but yes, so our current device is a prototype. We've been working on it for around a year now, and we're just starting to do local testing to quantify local air quality in Los Angeles. In regards to your question about how small it can get, currently we can make it a lot smaller, for sure. We used this design because we were just trying to figure out all the kinks. It's currently 3D printed, and we're using a Raspberry Pi microcontroller system. But of course, this could all be compacted, made more cost-effective, made smaller, more cheaper. In regards to measuring other types of chemical pollutants inside the air, Yes, that is something that we would ideally want to do in a final product. The major innovation that we have with this current platform is we're using a computational microscope, which compared to the existing technologies out there, can quantify a lot more. You're getting a lot more information. You're getting an image of the objects you're seeing out there. And there are also other types of sensors, CO2 sensors, nitrogen sensors, oxygen sensors, that of course could be integrated into the same platform to provide that all-inclusive measurement. Yes. And that's something that we are aiming to do in the near future for this project. But our current goal is to take the initial prototype, which is kind of a cartridge-based system right now, and make it a continuous monitoring system without the need for any interchangeable parts. And then from there, integrate all other types of interesting air quality sensors into it.
So it could end up in a home residential use like a smoke detector? Or
Yes, definitely. I mean, ideally, we want to put in something that you could put in your pocket.
Right.
Yes.
Thank you very much. Please line up other questions. Also, I have one question for all of the panelists, and it's around economic sustainability. Some of you are talking about, you think